Good day, Doctor. We are students from course Ordinary Differential Equations with course code SQQM3034, Group C. Our group project is about a ball with air resistance. Our group consists of 4 students who are Tia Jiawei with metric number 269556, Tan Lizian with metric number 279981, Chan Jero with metric number 280580, Saiful Zain bin Saiful Masri with metric number 281538.
What is differential equation? Differential equation is an equation that involves derivatives of one or more function. There are two types of differential equation, which are ODE and PDE. ODE involves ordinary derivatives with respect to one independent variable, whereas PDE involves partial derivatives with respect to multiple variables. So for air resistance, we often look at cases where things are falling. This type of falling, we call this as freefall motion because the object is moving only under the influence of the gravitational force. In this video, we will focus on ODE only. We take air resistance concept in the next example to show how to apply this concept for a ball with vertical motion. Other factors will be ignored here.
Hi, my name is Tijawe and my metric number is 269556. So our problem is about a ball with air resistance. So the question is, a tennis ball is hit straight upward with an initial velocity of 3m/s. The mass of a tennis ball is approximately 0.05 kg. Air resistance acts on the ball with a force numerically equals to 0.3 v, while v represents the velocity of the ball at time t. Find the velocity of the ball as a function of time, so that the mass m equals to 0.05 kg, k equals to 0.3, and g equals to 10m/s squared. The initial velocity is v equals to 3m/s. Therefore, the initial value problem is 0.05 times dv over dt equals to negative 0.3v minus 0.05 times 10. So that's all of my part, and I will pass to my partner to continue it. Thank you.
So here is the solution for our problem that's stated above. First, we perform a simple operations to get the ordinary differential equation 0.05 dv dt plus 0.3 v equals to negative 0.5. By dividing the differential equation by 0.05 and simplify it, we will get dv dt plus 6v equals to negative 10, which is a linear differential equation. Since it is a first-order linear differential equation, we can use the method of linear equation where we learned in chapter 2. We have here px equals to 6, qx equals to negative 10, and the integrating factor, which is ix equals to exponent 6x plus c1. Next, we have the general solution of linear equation, which is vt equals to 1 over ix times with the integration of ix times qx with respect to dx plus c. Then we just simply substitute the information and value that we have into it. And then we will get 1 over e power of 6x plus c1 times with integration of negative 10 e power of 6x plus c1 respect to dx plus c. To perform the integration, we have to use substitution method where we let u equals to 6x plus c1, du dx equals to 6, dx equals to 1 over 6 du, and we sub dx equals to 1 over 6 du into the equation. After the simple integration, we sub back u equals to 6x plus c1 and reduce the constant by defining k equals to c2 plus c. We continue to simplify our equation and we finally get our general solution, which is 1 over e power of 6x times with bracket negative 10 over 6 e power of 6x plus m. where m equals to k over exponent power of c1. In order to get a particular solution where our initial velocity is 3, when t equals 0, our function vt will be equals to 3, and then we sub the value into the general solution that we get just now. Hence, we obtain the constant m is equal to 14 over 3. Thus, the velocity function of the ball in terms of time is vt equals to 1 over e power of 6x times with bracket negative 10 over 6 e power of 6x plus 14 over 3.
Hi, Bismillahirrahmanirrahim. Assalamualaikum. My name is Saiful Zain bin Saiful Masri, and my metric number is 281538, and I'm going to explain the conclusion. So, in conclusion, the velocity of the ball can be found as a function of time using ODE. It proves that ODE can be applied for a ball with vertical motion using the air resistance concept. So more realistically, with air resistance, the acceleration of a falling object is the acceleration of gravity minus the acceleration due to air resistance. For some objects, the air resistance is proportional to the square of the velocity.